Good afternoon and welcome to Metro Home Theater Tech Tips. And in the background, once you hear our do not get too close to anybody because we are socially distancing, and don't forget to wear a mask if you got a hug.
Yeah, pretty much.
I'm Brent.
I'm Adam.
And today is what, Adam?
Backwards day, because you're over there and I'm over here, and it's really throwing me off a lot more than I thought it would. But today, we're going to be talking about bulk wire.
So what are we sponsored by today?
The letter B.
B?
Yeah.
What is B for?
B is actually, stands for direct burial. Because it's
That's
we're not
a D.
Yeah, well, okay, burial. It stands for burial. There we go. Close enough,
Well,
right?
The way this podcast is going, that's a good
Let's
word.
head that way. No, we're going to talk about our, it's sponsored by our direct burial Cat 5, Cat 6, as well as our speaker wire. So definitely check those parts out. Talk to your talk to your rep, talk to your distributor about those parts. You can find out availability and find out how much they are for that. So check them out. So we do have available for you is our Cat 5, Cat 6 direct burial, as well as our 14.4 and our 14.2 direct burial speaker wire. So definitely check those out as well. So
why are we reversed today, Adam?
well, today's going to be kind of interesting because I'm going to be doing some terminations while we're on doing the live. We're going to do some really cool picture-in-picture stuff. And you're going to go over that way so we can keep our 6 feet of separation, you know, so that we're good there. And then that way I can go ahead and get the top down. We'll get some nice little shots of doing terminations, and we can keep you in the shot since you're so pretty.
So let's talk a little bit about wire. Now,
Okay.
I'm old school RF guy.
Right.
So I got my training back in the 80s and 90s and long time
When?
ago. Yeah, yeah, before.
Okay, before.
The before time.
From the before.
From the before time. So for me, coax, much more so than Category 5, has or 6 now, has been my life. So let's talk a little bit about coax, what it is, why it is, and what the differences are. Because there are a lot of misconceptions about coax. In fact,
Right.
you and I were talking about this earlier.
Yeah.
And I'm going to put you on the spot
Okay.
because I'm going to ask some questions that, honestly, I'm guessing because this is not your world,
Right.
you probably don't know.
I don't.
What is the difference between dual shield, tri-shield, and quad shield?
I'm going to go with the number of shields.
Well, that's a good answer. In a dual shield cable, what shields do you have?
So, if I remember correctly, you've got your crisscross shielding that goes over that, and then you've got a foil shielding on there as well.
The foil shielding is directly on the dielectric, that is
Okay.
true. And then the braid.
Braid, thank
It's
you.
not crisscross, it's called braid.
It looks like a crisscross pattern.
It does, except to me, crisscross was a band.
Listen, I'm the programmer side, and I can run the wire and everything like that, but you actually had to understand why it was this way.
Well, because back then, particularly with analog,
Right.
it was very critical to understand what, why, and when you used what kind.
Well, in today's age, digital's digital, right?
Yeah, no.
Okay.
And we're going to get to that because one of the things when you talk about shielding is what cable do you use based on requirements. Now, originally it was 2 shields. You had a braid and a foil. The foil was directly on the dielectric. Can you switch to an overhead for just a second,
I sure
sir?
can. Yeah, I sure can. Hit the right button over here, and there we go.
So when you look right here, this is the dielectric. You had a foil wrapped around the white part and then a braid over that. Now, by the mid-90s, cable margins for cable manufacturers were already starting to get to 0.
Sure.
So they came out with, oh, we got to have quad. And DirecTV was coming out, and they talked DirecTV and Dish both into recommending quad cable.
Okay.
Now, is there any legitimate performance gain of quad over standard dual shields?
So, and you and I had this conversation before, so I'm actually cheating a little bit because I'm just using the information you told me from before. But from what you explained to me, in the average consumer's house, no.
No.
But if you were in a very close to like a radio tower or a cell phone tower of some kind, yeah.
Yeah.
Or for that matter,
Any high noise environment.
Yeah, high noise environment. So
The big difference was originally the standard dual shield was dropping in price. Quad shield was still very expensive, so they can make more money on it.
right.
Now, when you look at a quad shield cable, what makes it work is foil, braid, foil, braid. Now, when you're looking at shielding in a cable, the difference of foil, which is the silver wrapped right around the dielectric,
Right.
is designed for high frequencies.
Okay.
The braid is designed for low frequencies. Now, low frequencies is the 60 cycle noise that we see in a home, or
Okay.
50 cycle in Europe.
Sure.
So what you would have is 100% foil, because it's completely covered with the foil, and between 40 and 60% braid.
Right.
If you had braid only, you would want at least 60%.
Right.
But the two together, you can get away with less braid. Less braid did a couple of things. It made it more flexible,
Right.
and it also made it lower cost. Now, for the old guys that did CCTV, the original CCTV coax was an RG59 with a 90% copper braid on the cable, and you've probably never seen this.
No, that sounds like a very difficult wire
Oh,
to
it
work
was. It was a hard termination because it's like, one of those little finger sleeves you put over you that you can't get off.
with. Yeah,
So getting it stripped, getting it terminated was stupid hard.
Huh.
The foil makes it easier. And the foil rejects the higher frequency noise that you're going to get from self-services, fax modems, internet devices, things like that.
Right.
The braid is specifically for 60 cycle.
Okay.
Now, standard double shield really is honestly all you need for residential, unless you're on a yacht, in an airplane, or at an airport.
So, a couple questions. First and foremost, everybody who's on who's watching us live right now, thank you so much, as always, for checking in with us. And again, as always, if you have any questions or comments, or you have anything to say about what we're talking about today, please put it down in the chat. Or if you have something that's completely off topic, we're happy to talk about it as well. And as always, put that down in the comments or the chat section, and we'll talk about it there as well. If you're checking in live, do it there. If you're checking in after the recording and then you're just looking at the pre-recorded video, go ahead and put your questions and comments down in the comment section, as we do monitor those areas as well, and we do respond personally on there. Myself, I am on the channel every day checking the different comments, and Brent is brought in as well whenever you have questions for him. So please go ahead and put your questions and comments down below or over in the chat, and we'll get to those as we're talking today.
And we will provide all of our contact information at the end of the show.
Yes, we will. Now, one question I do have for you is why you purposefully called out the yacht.
Yes.
So why is it so quote-unquote noisy on a yacht?
Well, radar, depth finders.
Right.
There's a whole lot of electronics that work in upper frequencies
Okay.
and lower frequencies. Remember, with quad, you've got foil, braid, foil, braid.
Right.
So depending on what piece of gear you have, for example, if you're penetrating water, it's lower frequencies.
Okay. Okay.
So if you're doing a fish finder, it's going to be lower frequencies.
Right.
If you're doing over the ocean radar, it's going to be higher frequencies. If you've got radio, marine radio, RF, or heavy duty cell tower, higher frequencies.
Now you have a story about this as well, but it's not from a boat, but when we get to speaker wire.
Oh yeah.
That story. Tell
Yeah.
you know which one I'm talking
Okay.
about.
Now, again, back to the old days when people had ham radios.
Right.
I had a customer that actually at my time was the boss.
Yeah.
I wired his house for surround sound. This is prior to Dolby Digital, so this would have been 87, 88 kind of thing.
Do you remember the gauge?
I would have been 16.4
Okay.
to each speaker. I'm a simple guy, so instead of carrying multiple SKUs, 16.2 and 16.4, I just ran 16.4.
Okay.
It cost more, but it actually gave me more flexibility and honestly better noise rejection
Okay.
because of the twist. But this one speaker, the right rear speaker, periodically, every night at about 7 o'clock, God would talk to this man. And God would say something like, "This is QR27K, calling out, who's there?"
God works at a radio station.
God works at a radio station. So he calls me and says, what's going on here? And it took a little bit of research, and obviously no internet then,
Right.
no Google. It turned out that a neighbor had a ham radio broadcast working out of a tall station, a tall antenna. And the frequency was matching the length of that wire to that speaker.
Perfectly.
Damn near enough that it radiated. The incoming did not talk, but the outgoing did.
Right.
So what was the solution? We extended the speaker wire.
Put a little bit of an extra
Well,
extra
more than
length
a
to
little,
it.
but yeah.
Yeah.
Just changing the length of the wire affected its ability to resonate with that broadcast.
Well, because when you think about it that way, when you're talking about the radio frequencies, and this is all has to do with the bulk wires, how they work, how they operate, and also things to look at when you are looking into buying bulk wire as well, is things like the shielding capabilities of the
Yes.
wire. Now, with speaker wire, you normally don't have let me make sure I'm using this right, an STP.
Well, no, speaker wire is typically UTP, unshielded twisted pair.
Right.
Now, And this is where the world has changed slightly. In the early days, because we did not know any better, we actually ran shielded speaker wire with the drain.
Okay.
So when you got a piece of speaker wire, 16 gauge, 18 gauge, it had a foil around it, and it had a drain in it because we had not learned.
Right.
You know, we assumed and bought and over time you realize that did not matter except in a few bizarre situations.
Right.
Like God talking to you.
Yeah. Now, would that have helped his situation? If he had a
Possibly
shielded?
because it was the foil does higher frequency shielding.
Okay.
I honestly don't know.
Okay. Would have been interesting to see.
It would have been interesting to see.
So,
Now,
while we're talking about that, I'll go ahead and show a shot of this. So if you guys are interested in our bulk wire, our speaker wire, or anything else that we're working with here, what I'm going to do here is bring this over, and I'm going to bring this up here so you can kind of see the cabling. So it's very simple. With the 16.2, it's pretty straightforward. You've got a PVC jacket, correct?
Yes, sir.
And then you've got the shielding on the individual, positive or negative wire inside, and then you've got a stranded internals to it as well. So with this speaker wire, it's pretty basic. It's pretty straightforward. So it's very easy for something like this at a certain distance to be tuned.
and I'm gonna take
Yep.
This is not good. You'll see if you look at the jacket, you can see the lumps and the bumps.
Yep.
That's from the twist inside the wire.
Right.
Now the twist inside the wire is very specifically to reject 50 and 60 cycles.
Okay.
Because what does 110 operate at?
If it's 60 cycles.
60 cycles US, 50 cycles Europe.
Right.
So they pick something that works on both.
Right.
Now, one of the things, if you had bought speaker wire in the 90s, early 2000s, it would have been a much tighter twist.
Okay.
Now, the drawback to that is pure and simply cost.
Gotcha.
The higher the twist ratio, if you were to take 100 foot of wire with this twist ratio and 100 foot of wire with the old school twist ratio,
Right.
you would find there'd be about a 30% weight difference.
So we're actually saving money overall.
Oh, big time, because that 30% is purely in copper.
Gotcha.
And copper costs. So what they have done is much money time has been spent in testing to find out what is the actual optimum twist to reject the noise versus cost.
So that way we know we have, and honestly what it is at that point then you're not buying extra copper for no reason.
No, you're not.
Because you're not gaining anything by having this super
That is
tight,
correct.
Twist ratio in maybe
Normal
in a random
residential
normal
applications.
Now if you were in some random application where you were getting certain frequencies that were bombarding the speaker wire like yours was, you may need to have a tighter twist ratio.
Or more length.
Or more length to it. Hey Leo, it's good to see you, man. And yes, it's true. I'll go ahead and say that.
I'm afraid to ask.
So we're picking on Austin, as we do. So now, when we're talking about bulk wire, of course, one of the main things that we need to talk about is the application of the shielding. So I kind of mentioned the UTP, the STP,
Yes.
and different features like that. But we've also got issues like the CMR, CLR, and other features for
and
that as well.
We're back to application.
Right.
For example, when you look at your typical residential application,
Right.
in most, I'm going to say most of the US, a CMR, which covers CL2 and CL3 rated cables.
Close.
Well, CL3 still falls under CMR. The difference is how many floors.
Right.
That is, you don't have to worry about a tremendous amount of noise. You don't have to worry about toxicity of burn, or at least high levels of toxicity of burn.
Because you're not in a plenum application
You're not
where
in
you're
a
in the breathable
multi-story
air.
New York, Chicago, San Francisco, Seattle.
Right.
Larger areas where the buildings get very tall, they will not accept the CMR rating.
Right.
In those buildings, they want a CMP or a plenum rating.
Right.
And a plenum rating, aside from costing you a lot of money, because there's a whole lot of government testing and assurance that goes into it,
Yep.
what it really gives you is a low burn toxicity and low burn rate. What that means is, in the event that this catches fire and starts melting, or just starts melting, it will not emit high toxicity, and it will not emit a lot of smoke, and it will not burn quickly. And if you're a fireman going into a high rise, the last thing you want to have to deal with is all the stuff in the walls trying to kill you.
So just to kind of give you an idea, one of the things that we run into with this, what I have here are two separate fiber. We have riser-rated fiber, then we've got the plenum-rated fiber.
Plenum-rated fiber.
There we go. We'll say that 10 times fast. But what you run into with this is that when you are using the plenum-rated one, a lot of times what you run into is a jacket that's just a little bit tighter and not as pliable. So it's
harder to terminate.
A little bit harder to terminate in those applications. So that's really the biggest differences, because the actual chemical makeup of the outer jacket is different between the riser rating and the plenum rating. And so that's because in the riser rating you can get away with just a standard PVC jacket
or PVC combination.
Exactly, because in those locations, if it were to, God forbid, catch fire, the smoke or the fumes from it would not get into the breathable air space that it's in. Plus,
be recirculated.
Plus, it's not as important for the burn time on that as well. So now
there are some drawbacks to that, and we're going to get into HDMI cable construction in, I believe, the next broadcast.
Yeah. So,
but when you look at an HDMI cable, the reason you don't see a lot of HDMI cables that are plenum, because the stiffness of the plenum jacket makes terminating, particularly higher gauge if you want to go distances, prohibitive.
Right.
The failure rate is tremendous, which is why you don't see a lot of 10, 15, 20, 30 meter plenum HDMI cables at any kind of bandwidth over 5 or 6 gigs and at anywhere close to a reasonable price.
Right. So
that's where fiber really kicks butt.
Yes, it does. So what I'd like to do, Brent, is I'd like to go ahead and start terminating some of these cables to show people what they're going to run into during this.
Before we get to that, if you'll go overhead real quick, I want to cover a couple of things on coax as you start to terminate.
Sounds like a plan.
When you're looking at coax, there's two primary coaxes. We're not going to talk about shielding. We already covered that with dual, triple, and quad, but there's CCS and BC. Now, they have their applications. CCS means copper-clad steel. This will be a stiffer cable, less flexible. The center conductor will be steel, and then there'll be a copper flashing around it. The dielectric and the foil and the braid typically are the same.
Right.
When you get to a BC, which is more flexible because the center conductor, the stinger, is pure copper.
Right.
It is easier to work with, but it is more money because that much copper costs a whole lot more money than just flashing a steel stinger.
Right.
So, application. If you're doing video surveillance in any way, shape, or form, use BC.
Right.
Cable, you can use copper-clad steel because you are operating at higher frequencies. Now, the skin effect.
Do we want to get into that?
Well, it's interesting because I got a call the other day referencing some speaker wire. Somebody was asking me, what are your thoughts on speaker wire? Strand count versus solid, skin effect, blah, blah, blah. Here's the thing. Speaker wires operate at very, very, very low frequencies. 20,000 sounds like a lot.
Yep.
It's nothing.
No.
However, when you get up into the cable frequencies, 450 megahertz, 900 megahertz, 2500 megahertz, you can actually get away with a copper-clad steel, assuming that when you are terminating that wire, you do not cut all the way through that copper.
Right.
So you have to be very careful not to cut too deep into the stinger. Whereas if you have pure copper, you can cut into that stinger and it doesn't know the difference because it's still copper.
Right.
You cut through the copper flashing on this and it's steel.
Right.
It's like putting a giant ravine in the middle of the road and you got to get over it.
Right. So there you go. So so when we're talking about speaker wire and we're talking about skin effect, while skin effect is a real quote-unquote phenomenon,
particularly in HDMI,
but it's in the super, super high frequencies. So when you talk about speaker wire,
not analog interconnects, not speaker wire.
While the location of the electricity that's going through the wire does grow or shrink, the actual point that it's going through never makes it all the way out to the actual skin of the wire itself. Yes. So what I'd like to do then is I'd like to go ahead and I'd like to terminate some Ethernet wire.
Okay.
So Cat 5 and Cat 6, and I've got both things here as well. So pretty straightforward. We got Cat 5, we got Cat 6, and we're going to talk about the construction of it while we're going through this. Okay. So I'm going to start with the Cat 5.
Now, is this both UTP?
These are both UTP. And Brent, do we carry STP?
I believe we do.
The shielded?
Yes, because we also carry shielded terminals.
There you go. So with that, we're going to go ahead and I'm going to get
You're
this
going to ask me an inventory issue. That's just not fair.
I know. So as you can see over here, Brent is on camera over here. I am going to be doing some down shots
We
with
are
this.
socially distancing.
Yep. And I'm actually going to zoom in, and pardon the shaky cam here, guys, as we go in a little bit. And we'll go ahead and show the termination process. Is it going to focus? There we go. Okay, so now what I'm going to do first and foremost, and this is the way that I like to terminate things, and everyone is just a little bit different. Brent, would you do me a favor? That
Yes, sir.
blue handle up there at the very top, if you would grab that for me. Up, up, up. That one. There we are.
Do you need the coax strippers?
I do not. I've already got a pair. I thought I had everything I needed. Turns out I didn't. There we go. So we've got our...
And just in case nobody realizes, this really is our working lab.
It really is, yeah. So all my tools and stuff are here. So now I'd like to point out first, you'll notice here that I have new written on this. Brent, why do I have new written on this? Do you know why? So
because the stuff around here gets beat up pretty bad, and the quality of your tool is very, very important.
it's very, very important. Now what you'll see in here, of course, and with the termination tools, there's actually the teeth, there we go, there's actually the teeth of the crimpers. Now, what those teeth do is they actually press up against the copper teeth of the RJ45 termination. Those are the blades that actually push into the wire itself. So what will happen is over time, even while you're out in the field, especially while you're out in the field, dirt and dust and little pieces of plastic from the terminations can actually get down inside those teeth. And what happens at that point is it can't get a full tight termination, and to where the metal teeth on the RJ45 won't pierce all the way into the category wire. And Brent, how does that affect things?
Well, it certainly affects bandwidth. If I can take your space for just a second, I'm going to grab the red here. And what you should have
You're zoomed in.
is
There you go.
8 even penetrations. But what happens is over time, it's just like tires on your car.
Right.
You'll get an uneven wear. So if one of them, for whatever reason, is not giving you the full penetration, you're not going to get full bandwidth. And as bad as it is on networking, where you're really not using all 8 conductors,
Right.
in HDMI, particularly HD-based and even more so the inexpensive extenders,
Right.
the failure rate because of this is the biggest issue we see.
Very much so. So with this here, I've already stripped this back, so we've got just the inside twist for that. Now, of course, as everybody knows or should know, we've got different twist ratios depending on what pair that we are working with. And I'm actually going to erase
Now,
this
why do
here
we
so
do
you can
that?
see better. Because when you are doing this here, and correct me if I'm wrong with this, when you are doing different twist ratios, you're actually making sure that from one pair to another pair, we don't get crossover. We don't get crosstalk.
Right, crosstalk, and that's because of the skew.
Right.
Having different twist ratios removes the skew. If they're all the same twist ratio, and it's interesting because we want to have better control of that in HDMI, but we also have all the additional, it's XLR instead of a twisted pair,
Right.
and the additional foil and braid.
Right. So with this here, what I'm doing is just being very
Quick?
very quick, as quick as I possibly can go. And we're going to lay this now. Now, of course, I am of the school of thought that I like 568B. So I always lead with my white, orange. Let's see. Leo. Yeah, honestly, Leo, if you're using copper-clad steel or copper-clad aluminum, you can do those. I prefer myself using just straight copper all the way through with everything that I do, because then I don't have to think about anything. But you can use the copper-clad steel or copper-clad aluminum to do what you need to do in certain applications.
But not for video surveillance.
No, yeah, for video surveillance, because you're using just the lower frequencies for that as well, then you want to make sure to monitor that. Now, Brent, what is the correct color scheme for T568B?
Well, 568 is orange, white, orange, green, white, blue, blue, white, green, brown, white, brown, as I recall.
Right.
I got it right? I think so.
I think you did. Let's see. White, orange, white, green, blue,
Green, right.
white, blue, green,
You see, I lead.
white, brown.
You lead with white, I lead with the. But yes,
Yeah.
you
Yeah,
lead
yep,
as
yep.
you read it.
Yep.
So yes, I got it right.
What I'm doing here, and this is just my rule of thumb, is I'm actually using the size of my finger as the point to cut across this here. Now,
And
what
I do
you
the same,
won't see
except
me
I use
do-
my knuckle.
You use your knuckle?
You know, what I do, because now, if I may take that for a second, I will put I use my knuckle. Right.
Yeah.
Oh, yeah, sorry. So I look down there and give myself, lay everything out.
Yep.
Then use my knuckle to cut it. Now, I use scissors. He's using those.
Nope.
Are you using the scissors?
I am going to use the scissors. And why do we use scissors, Brent?
Because they cut with sharpness, not with pressure.
Correct. So what you will all see us do, and in fact, if you call us up for tech support, what you will see is that if, as we're talking to you about having issues with HDBaseT extenders or the non-HDBaseT extenders or any kind of termination that has to do with RJ45, we're going to say, please do not use your side cutters. The reason for that is these side cutters, what they're doing is they're actually just pressing. And even though it's a sharp point along that edge, it's still a pressure point that you're just pressing up against it. And so you wind up with this, let's see, let me draw it out. You wind up with a knuckle, basically. And so you're going to get a little bit of a sharp edge like that because you're pressing in on this and it's just kind of pinching it off. Whereas instead, if you are using an actual pair of scissors, you get a nice flat cut across that instead.
And they're a whole lot less expensive.
Yes, they are. So honestly, while I still prefer to have my side cutters with me on every job that I go to, a pair of scissors are very, very high importance when you go to actually terminate those as well. In fact, we've talked about this a couple times in some other videos that we've done in the past. So if you have any questions about those, please feel free to read back into what we've already done in the past as well. So I am going to line these back up because Brent has put them out of order. And I am blaming you live on air.
That's okay, I'm blind. I can't see the color code anymore.
Let's see, we'll go ahead and lay that out there. Green, white, brown, brown.
Now, what is the performance difference between 568A and 568B?
Nothing.
And why is there 568A and 568B?
Because it started out with, and help me out here, who started it?
Xerox and IBM.
Xerox and IBM. So when Xerox and IBM first, or who did it first? That was.
I honestly don't remember, but when I'm going to say IBM just because they've been around forever.
Sure,
but
sure.
Xerox, when they came out, it used to be coax, called Twinax actually.
Right.
When they started using networking category cables, one required it one way, the other required it the other way, purely for warranty purposes.
Right.
Nothing to do with performance. But I have seen some incredible arguments online with guys claiming that one was performance superior to the other.
Right.
And coming up with some real interesting but unsubstantiable reasons for their... When you look in our catalogs and our manuals, and we've said this before, we put in 568B.
Right.
Why do we put 568B in, Adam?
Because we have to say something.
And if we
because
don't,
we're going to get questions about it, and that's the main reasons with it. So if you're going to use 568A, that's perfectly fine. If you're going to use B, that's perfectly fine. Just make sure it's the same on both ends.
and don't laugh about that one.
Yeah. Now, what I'd like to talk about here as well is what I just did here with the termination, and I was trying to show that on camera while we were talking, but of course we get the glare of it. And if you all can tell, let's see if it focuses.
I don't think you can.
No, maybe not. But what you will see along the top of your terminations, it's actually on this side here, is the easiest place to see it, is you will see 8 shiny copper dots pressed all the way up against the edge of the termination. And the importance of that is because we want to make sure that we have it flat up against the top and that it's nice and straight across. Because if it's not straight, as we were talking before, your termination tool is actually dirty and needs to be replaced.
Now, the other thing you'll see, if you'll back off for just a second and
sure
give
will.
me the overhead.
Yep, you're on it.
When you're looking at the 8 copper dots, they all need to be in a straight line. If one of them is higher or lower than the others,
Yep.
that is absolutely because your termination tool is wearing out. That means you did not get proper penetration of that pin, and you're not getting full bandwidth of that pin.
Right.
That's very, very critical as we deal with HDMI.
Right.
And by the way, if you follow HDMI rules on your networking, I promise you your network system will run better.
Right. It really does, and honestly, this is something that we've learned because of our HDMI extenders, and so we've taken that knowledge and we've applied it to our networking when it comes to our cameras for surveillance cameras. Because a lot of times we get calls about problems with surveillance cameras, and maybe the power is dropping out on the camera every so often, or maybe the picture is extra pixelated. All the cameras are working fine except for one where it's just not quite getting the best possible bandwidth into the NVR. And a lot of times just having them replace or re-terminate the ends makes a huge difference. Now, while we're talking about the terminations, what should be used, what should not be used with terminations? Now, we're not going to name names.
No, and this gets politically sensitive,
Yes.
but we would prefer not to use the push-through.
Correct.
Now, here's why I do not like the push-through. Inherently, there's nothing wrong with the push-through.
Right.
The problem is the tool.
Right.
As you mentioned earlier, maintaining your tool is very critical.
Yes.
And for those of you guys that are old enough to remember the introduction of twin blade razors, the commercial showed the first blade pulling the whisker out and the second blade cutting it.
Yep.
Before your time. Here's what happens. If your tool, your compression tool, does not have fresh blades on it this morning,
Yep.
when it goes to penetrate or cut that wire down, it will not cut it evenly and will actually draw the wire out from under the blades and thin the copper.
Right.
And when this happens, you get lower bandwidth.
Right.
So, you know, I don't want to hear that we're saying the tool and the process is poo-poo.
It's not.
What we're saying is it requires a much higher maintenance of your tool to make that process work.
Very much so. So now that we've talked about that, what we're also going to talk about is another, we're not going to name names, of course, we're on the clock. So another brand that is primarily sold in hardware stores.
You're not a fan of the blue and white package?
Yep. So the problem that we run into with that, it's not because of they're not ours. It's actually for a very specific reason. And I'm going to go back here to the top down. So what we're going to do here, and I'm going to use this here as our cable here. So let's say we have one of our strands, our twisted pair cables in here. We'll do this here to give you a second one. So when you run into this particular brand that we don't like so much.
We don't encourage.
We don't encourage. What will happen is when you slide it into, we'll start with ours, because when you slide it into one of ours, it's just the right size for a Cat 5 and a Cat 6 cable. I mean, and by size,
it's a snug fit.
Particularly meaning the actual termination itself.
The holes in the back.
The holes that you actually get fed into the termination itself. And what will happen with ours is it will go in there and you will have the teeth from the bottom of the pin and they will get fed directly into that termination, and it's nice and tight and snug and everybody's where they're supposed to be. However, certain brands, what they run into, and this is just mainly because they're trying to be able to encompass both Cat 5 and Cat 6 at the same time.
To make your life easier.
To make everybody's life easier. And it's not a bad reason, but it's a bad...
it's a bad answer.
Bad answer. So, what they run into is that their openings for the cables to go into are slightly oversized, and I'm going a little bit exaggerated here for the size of this. And what will happen is as the pin is being pushed up inside, it's actually going to move the cabling inside of that connection off to one side. And what you wind up with at this point is an unsecure termination. And what that will do is it will actually decrease the capabilities of the bandwidth going through that connection. And it's very, very, very important, especially when we are talking about HDBaseT. We're talking about
10 gig networks.
10 gig networks. We're talking about all of these different services that we need extra high bandwidth for. And because if you don't have a good termination with that, you're going to run into problems. So that's why we don't recommend those. What we're looking for specifically is what's known as BICSI.
BICSI.
BICSI, and it's a certification that we have applied our terminations to ensure that they are made of good quality.
And it's not us doing the certifying.
Correct.
It is a governing body for network and telecom.
Right. So, now that we talked about terminations, I'm going to go and terminate a Cat 6 cable.
Ooh, not fun.
Yeah, no.
Does this got the media spline in it?
This does. So, and explain the reasons behind the media spline as I get things ready for us.
Would you strip it back a little bit?
I will, yep.
When you look at a Cat 6, typically Cat 6A, with the media spline on it, what that does is it actually keeps the wires all in a very specific relationship to each other.
Right.
This also improves bandwidth because we're controlling inter and intra-pair skew.
Right.
And crosstalk.
Right. So this allows us to have a twist ratio on the individual pairs.
Which is tighter than a Category 5 cable.
Correct. And it also gives us the ability to have a twist ratio of the pairs of wires inside. So it actually has a twist to it inside of it as well. So this spline that's on the inside, and that's a little difficult to see.
Yeah, now the spline is more, when you look at the spline, that's more for higher frequency. The twist inside the cable is more for lower frequency, and by doing this, it keeps the performance level of the cable and inductive noise also low.
Right.
Now, on this note, while you're doing that, what is the biggest difference between UTP and STP and why?
You tell me, Brent. I don't have a good answer for that one.
Well, STP is shielded, and there's several types of shielded. There's foil only, braid only with drain, and braid and foil. However, anytime you do an STP, you want to only do that in a high noise environment.
Right.
Because there is a lot of noise inside of that cable, just like there is in an HDMI cable.
Right.
The drawback to that is if you're in a high noise environment, marine, airport, some kind of commercial application, when you put that shield on it, you actually reduce the length that you can travel with the data. It does not improve it. It reduces it because of reflectivity. You and I were discussing this earlier when the phone rang, but we're going to take a Super Ball.
Right.
Now, do you know what a Super Ball is? You know, one of those really stupid, strong, bouncy balls, hard like a rock?
Yep, yep.
We're going to take it out to the basketball court behind your local high school. We're going to throw it on the ground.
Yep.
It bounces up in the air and it just goes away.
Mm-hmm.
You don't get hit, you don't get hurt. We're going to take that same Super Ball, we're going to go to the handball court.
Okay.
We're going to throw that ball hard on the ground. And that ball is going to go up, hit the wall, hit the ceiling. It's going to bounce around, and your chances of getting hurt by that ball
have just increased.
Increased dramatically, plain and simply because of reflection.
Right.
And it's the exact same thing on a cable. A shielded twisted pair will have greater return on itself. The purpose of unshielded twisted pair is to protect the signal from outside noise, but also to allow enough escape that it doesn't interfere with itself.
Right. So we actually had a really good question. Abraham, nice to see you, my friend. He's asking, would we recommend using the blade on the crimping tool to cut instead of scissors?
No.
Correct. And actually, the blade that you're talking about is this one here. And you are correct. At this blade point here, it gives you a nice little flat edge to cut across. And while in many circumstances that would be a great way to do that, the problem that you run into is that it's still a pressure point. With a pair of scissors, what you run into let me open this up here, you actually get a cutting shearing effect as they cut across each other. And so you get this effect where they will go like this, and they're cutting at each other like that.
It's a smoother, flatter cut.
Correct.
Also, when you look at these, it's a blade cutting down onto a flat surface.
Right.
And it's that flat surface that causes the problem.
Yep. And so again, that's more of a pressure cut like that, instead of it being an actual scissor cut where it's actually cutting at a point. This point here, as it goes across, is actually a nice cutting point rather than that. That's why a lot of times when you take, if you were to take your, I got a really good example of this. If you were to take a steak knife and you go at your steak direct, straight down, if you go at your steak like that, it's not going to cut. It may do like a surface cut, but it's not going to go all the way through it. And you would have to put a lot of extra force to actually cut through that. And by the time that you get all the way through that,
you've torn it
steak,
more than cut it.
You've torn it more than cut it. Now, if you were to take that same knife, and let's say it's a very sharp knife, it's not something super dull or anything like that, but it's actually nice and sharp, and you go at it with an action to it instead of going straight down, you go at it more of a moving action. You're going to be cutting through that much better than you would in another application. So, no.
Unless you buy a minute steak from the grocery store and use a butter knife.
Yeah, that's different. Yeah, that's a different effect entirely. So what I'm doing here, and I've had to start over a couple times because it's been a little bit since I've done Cat 6, and what I did before was I broke off my white blue connector here.
Overcut it in the stripping of the jacket, did you?
I sure did. So I wanted to back it up because I wanted to make sure I didn't do it with the others as well. Now, my technique is a little different than others. When I go in to do the termination here, I'm actually having quite a bit of excess. I'm not as quick as some of the others.
Stop before you do that. I was going to have you stop. I want to.
Oh, yeah.
Now, he and I do this differently. Once I work them out, what I will do is I work them out that way, then I lay the whole thing out. Oh, sorry. I lay the whole thing out so I can wiggle them out like that, and it gets it smoother, quicker.
Right.
But being old and arthritic, I'm going to let you do it.
Hurts a little bit more, right? Yeah.
Yes, it does.
So what we've got here, of course, is we'll go ahead and lay it back out again with 568B. In my mind, that is the correct way to do it. And I ensure, now, and this is actually a nice little tip for you guys out there who are starting up your own company or are heading up a team. It's always good to have everybody on the team using the same standard. And the reason for that is because if you have multiple people terminating wires inside of a single building, you want everybody to do the same
Been there, done that.
terminations on both sides. And here's what happens. In previous years, you would have the what was that
Crossover
cable called? Crossover cable. And what that cable would allow you to do is to do like an ad hoc connection from one device directly to another.
Right, without a network
Correct.
interface.
And so you really had to, you had to do it that way in those instances. And so what I'm doing here is I'm just massaging the cables to get them nice and straight and orderly. And again, I'm using about the finger's width there.
Does that come with an extra tip at the end?
This what now?
The massage?
No. You're just a dirty old man. We'll go ahead and take our scissors. Now, here's the deal. Before I started working here, I was a cutter's man. I would use the cutters to cut across that, and I have yet to have anybody call me back because of a bad termination. I'm not patting myself on the back for that reason or anything, but I am saying that in a lot of circumstances, it will work perfectly fine. However, it is not the recommended way to do it. Now, what we said before about your termination and looking at the end of it for a Cat 5 cable goes completely out of the window when you use a Cat 6. Do you know why, Brent?
Well, in most cases, the Cat 6 is a staggered high-low, high-low, high-low.
Correct. So let's see if I can bring it up there
Because
and show
the
everybody.
wire gauge will not lay flat side by side.
Oh, it's not going to focus. There it
You
goes.
can draw it easy enough.
Nope, yep, it's right there. Right there at the very tip, you'll see that you've got 4 that are on the same level and then another 4 that are on a slightly different level.
Like that.
Correct. Go ahead
They
and put
still
this in
need
here.
to be in 2 flat rows.
Now, these are, of course, both RJ45 terminations, so you can use this in both applications for the Cat 5 and the Cat 6. So when you go to plug it into the terminals, it is the same terminal. And so there is your termination. Now, of course, we have many different wires to talk about, so I'm going to go through very quickly and get over to them as well. So we've terminated a Cat 5 cable, and we have terminated a Cat 6 cable. Abraham, again, thank you so much for that question. That was a really good question about that. And Leo, again, as always, it's always great to see you in the chat with us. If you have any other questions, feel free to put them down below as well.
Are you terminating a piece of coax?
I'm going to terminate a piece of coax. Now,
Quad or regular?
I'm going to go with a regular.
Yeah, wimp.
Huh?
Wimp.
Wimp, yeah,
Wimp.
because it's quad is a very difficult cable to terminate, and I don't want to fail at it live on air. I'll be perfectly honest about that. So, Brent, which one of these is quad and which one is non? Can you tell the difference? For me, it's actually
I'm
pretty
going to say
straightforward.
that one's the quad, but I'll wind up being wrong.
Let's see what it says here on the side. You are
This is BC on this one.
correct. This is the
And
quad.
do you know how you can tell that?
It's a little bit thicker.
No.
No?
The dielectric's a little bit smaller in diameter.
Ah, see?
Now, when you look at a quad terminal,
Yep.
can you give me overhead
I sure
and the
can.
black pin?
Alrighty there, and black pen.
When you look at quad terminals and regular terminals,
Go up.
oh,
Remember, we're zoomed in. There you go. Perfect.
so the outer sleeve is going to be the same size
Mm-hmm.
because you're still dealing with essentially the same outer diameter.
Right, still RG6.
What changes
Right,
is the dielectric.
right.
So what you will have on an RG6 quad, in order to give room for the 2 braids and the 2 foils,
Mm-hmm.
is the dielectric will be smaller in the inner sleeve. You know, this inner opening that it slides into.
Right.
Will
Will be a
be
little bit
smaller.
smaller.
Which is why it's very hard when you look at trying to put a regular terminal onto an RG6. It really, really sucks.
Right.
It's because you're pushing into the braid in the foil, not under the foil.
Right.
It's the exact opposite when you're trying to put a quad
Yep.
on a regular one because the dielectric's bigger than the opening.
Right. Right. So now this is actually kind of interesting because we did have a call about this, and I have yet to hear back from the gentleman. What had happened is what happened was he called in and said that with his RG59 and 18.2, so he was using this in a surveillance application. With the RG59, when he would have the BNC connectors on the end of it, they were loose is the descriptive word that he used. And normally loose is kind of a what's the correct way to say that? It's kind of a catch-all description for it, because a loose on a BNC connector could mean many things. It could be loose when you actually have it plugged in to the terminal, or it could be loose between the termination and the cable itself.
Well, when you look at the current compression terminals, the outer sleeve, the jacket will not fill up, the cable will not fill up to the edge of the outer sleeve like it did in the old days.
Right.
In the old days, the compression was done by actually compressing the outer sleeve down around the cable. On the new versions, it's by pressing an inner sleeve inside of the outer sleeve. So it is not uncommon when you were to, if you were to look at a coax where you'll have a gap around it on the outer sleeve of the terminal.
Right.
That is not wrong.
Right.
Now, if it physically moves around it, that's another problem.
Right. So, I didn't have another RG59 cut off. Those are all RG6s over there. So I'm actually going to do an RG59 with the BNC connector.
Oh, and I see with the 18.2.
With the 18.2. So we'll go ahead and get this over here for that. So what we're working with here today, we've got our RG59 and our 18.2 Siamese together. And this is a great wire for surveillance purposes. So I'm just going to cut back the power cable because we're not going to be messing with that today. But we are going to take our RG59. Now we've got our stripper. And we're just going to simply, now what I like to do is this stripper has got this little bump out portion to it. And so what I like to do is have that portion of that bump out be my stopping point. So I will open it up, feed it in, and I'll use my finger as a stopping measure for it. And then I'll close it down like that. That gives me a nice point to work with. That's kind of my measurements that I use. So once we do that, I'm going to go around a couple times, go around the other way a couple times, hold the front, and I'm going to pull that out. Right?
I can't see it, but I'm going to believe it. Yep, looks
There we
very
go.
good. Ooh, and this is a copper braid. That is a proper CCTV RG59.
Yep.
Now, that is, I am guessing, a 70% braid.
Probably.
That is not a 100 because we don't need it anymore.
Probably. Correct.
Now, I assume you're going to be very careful to look to make sure there's not
Yep.
any copper strands wrapped around the stinger.
So when you guys are out in the field dealing with this as well, make sure that your strippers are nice and sharp. And again, these are items that need to be replaced every so often. These are maintenance items. They're cheap enough to where you could probably pick up a couple of them, leave them back at the shop, and then periodically grab a new one. Maybe every couple months or so you can grab a new one, or if you notice that one's becoming dull. So I'm going to make sure that I don't have any copper that's at the center stinger at that point. And what I like to do is I like to kind of flare that back a little bit. It helps me to make sure that everything goes in nice and smooth. So from there, I'm going to get my BNC. And these BNCs come inside a little baggie because the stinger is a separate piece. So you need to make sure to have that ready. Some of the baggies some of the 50 packs of these come with these outside of the bags, and then there's one baggie that has all of your stingers inside of it. So whichever one you order, it just depends on when that one was manufactured. You can find that out as well. So I'm going to take the stinger here, and I'm going to feed it onto the end of the copper. Oh, and look what I did. I bent it. That's okay.
What is bare copper?
It's bare copper. So there we go like that. And what we're going to do from there is down inside. Let's see if you can see that there. We're just going to make sure that that goes all the way in through that. So I'm going to kind of peek down through the top.
Which is why he's doing this
here.
and not the old man.
And I'm probably, there we go. Okay, so now I've got the tip in there. Now you'll notice it's not all the way through to the very edge of that there. So I'm going to make sure that I go ahead and put some pressure on it, and I put a little bit of a twisting motion to make sure that everything's getting nice and tight inside there. And I'm noticing that it's coming up. Now it's not coming up as much as I want it to, so I'm going to give it a little bit more and see if it goes to where I'm going to be at. Now something isn't feeling right here. Just make sure that everything is good to go. You know, I was all worried about it doing the quad shielded, and yet here on the RG59 I'm still running into problems. Did I grab Cat 6 instead of? I did. This is RG6. That's my problem. That's my problem. There's always going to be something. Hey, we're all human around here. We can all mess it up. So I'm going to switch over to an RG6.
Yeah, of course you are.
Yep, that's what I'm going to do.
Now, I thought you said you only had RG59 terminals.
I thought so. I thought that was it. Maybe these are samples or something from something else, or a really old batch. I'm not entirely sure. I'll have to find out later. But we're going to go back and do this all over again. There we go.
Now, the exact same problem as I was discussing about quad versus standard RG6.
Right. So the RG6 was actually it was actually too large to fit inside there, and it was pushing up against
on the copper.
It was actually pushing
on
the braid. So that was causing me an issue as I was terminating that. So same procedure here. I'm just making sure that everything's good to go. And we're going to take our stinger, and we're going to fit that on the end of the copper.
Now, the big advantage of this is you can go further with an RG6 than with an RG59.
Correct.
It's an 18 gauge stinger versus a 22 gauge stinger.
Yep. And there we go.
And it's actually much easier to terminate.
Yes, it is. So there, right there, we've got the stinger all the way in the cable, and there we are good to go. So now that I have that there, I am going to take, and in fact, I'm going to use my own personal crimp tool, This is not one of our Metro ones. This is one from my installation days from before. So this is one. Yeah, I know. This is actually my favorite one. Not to say that ours here at the office is not my favorite one. This is just one that I prefer to use in these applications. So I'm actually going to take this here. I'm going to flip this around to the BNC connection, and I'm going to turn that. Let's see if I can get that. Is that the correct one?
I'm not feeling this one so far. I got to be honest with you.
No.
No.
It's definitely.
I prefer ours because it guides the wire.
Yes, it does. So we'll do that there, and I'm just going to pull that down there, and I'm going to tighten that up, make sure it's good to go.
Yeah.
There we go.
I'm definitely feeling ours.
You're feeling ours better
I'm
than
feeling
that
ours.
one?
Now, hand me ours a second so we can...
I don't think I even have it over here. I think that's why I didn't grab that one. Ah, there we go. No, that's not it.
No.
Is there one all the way up there?
Yeah.
There we go.
Okay. Now, just for what it's worth, the reason I prefer ours is it guides the wire.
Yep.
So you're not having to hold it in place.
Feeds down inside.
It is definitely a larger tool.
Yep.
But the chances of a disaster are greatly reduced, and it's also ratcheting, which I really prefer.
Ratcheting is nice because then even if you release pressure, the pressure maintains constant all the way through.
Yes.
So with your RG59 and RG6 BNC connections, make sure that once it is in there, it's nice and tight, and I'm putting quite a bit of actual pressure on this to make sure that everything's where it's supposed to be.
Assuming you've terminated correctly, you will pull the terminal out of the device before the terminal off the cable.
Correct. And that's the best way to look at it, because this should be extra tight. So in the gentleman who called in earlier, in his case, if it is loose at this point here, then there's a good chance that you're trying to put either an RG6 on an RG59 cable or vice versa. Right. You may be trying to put an RG...
We used to sell serial digital cable.
Yep.
And it was not uncommon for the serial digital to have a smaller diameter outside jacket.
Right.
So when you looked at it, there was movement, even though it was snug in the terminal. It looked like there was movement. There wasn't.
Right. And it's actually one of those things to just... Well, in his case, what was happening is he would move the wire and he would lose picture. And so there's something else going on with his termination.
He was probably using an off-brand cable that was not...
Could be.
And we have seen in the old days when we had Mini 59 with 24 and 25 gauge.
Yep.
If you didn't have the right terminal.
Yep.
And sometimes it was hard to know.
Yep. It would happen.
It would happen.
With that said, the other one that we can do is a fiber termination. However, we are running out of time.
And we've done that several times.
And we've done it several times, so feel free to go back to our other videos to check that out.
One of the things we did not get into today is speaker wire, and that will be a future episode.
Yes, it will.
Because there's a lot to talk about there.
Yes, it is. So, and in fact,
we have many conversations about that around here.
Yeah. Now, one of the things that I did want to mention, and one of our sales department asked me to do this as well, the difference between Cat6, Cat6e, and Cat6a. So primarily, the biggest thing is that Cat6e, while it is a real type of cable, it is not a TIA standardized cable.
It's not a ratified spec.
It's not a ratified spec. So while it is a cable that you can go out and purchase, just be aware that it's not a spec that is a quote-unquote real or certified spec.
It's not ratified. Until it's ratified, it's just somebody saying, hey, I've got.
Yep.
It's a claim.
Which is fine. If it works, it works. But the thing is that you don't have anything to back it up with. So you've also got Cat6,
Cat6A are both ratified,
yep.
And there are absolute performance specs that a cable has to be built to.
Which with a Cat6 cable, of course, you've got a 1 gig capable cable, and what you are looking at, and in fact, let's see if I printed that off correctly, the potential bandwidth of a Cat6 cable for 1 second of bandwidth is 1 gigabyte of information. You can go further, you can go higher than that on a Cat6 technically.
Sure, how do you support a 10 gig bandwidth?
Exactly.
10 gig network.
Now here's the thing, in a 10 gig network, it's certified for 1 second of 10 gig pass-through on a Cat6A cable. Now the biggest difference between a Cat6 and a Cat6A cable?
Twist ratio and gauge?
Twist ratio and gauge. So the twist ratio on a Cat6A cable is going to be a little bit tighter, and the gauge for it is going to be a little bit larger than on a Cat6 cable. But enough to where that's enough to make a difference.
And it does help with capacitive loading, because what does capacitive loading do?
It messes things up.
It slows things
It
down.
slows things down and makes it all not work correctly.
And we know that from HDMI.
Yes, we do. So, Brent, the upcoming episodes that we have, of course, going on this week. By the way, everybody, thank you again for checking out the video with us today. As always, if you have any other questions or comments and they come to you after the fact, come on back to the video, leave it down in the comments, send us a direct message, or, of course, I'm going to put up our contact information on the screen here in a little bit. But you can call us and email us if you have any questions or concerns about what's going on with that. But again, as always, thank you for checking out the video with us today. What we have coming on later on this week is HDMI cable construction.
Right, which is, I love that one.
Yeah, so that's gonna be one. That's gonna be a you episode. So I get to ask questions, so you get to answer them.
Oh boy.
Yeah. So that's gonna be the good, the bad, the ugly HDMI cable construction, and we're gonna be talking about.
And by the way, we know who the good is.
Sure.
Not feeling the love in that comment.
Sure. So what we have, we're going to be talking about, of course, bad cable design, good cable design, ugly cable design that's still maybe good, or just ugly because it's ugly. Then, of course, next week we are going to be talking about understanding infrared.
Ooh.
Yeah.
You know, it's amazing how much of that still happens out there.
It happens a lot. So I'm Control 4 certified, and I still use IR in a lot of.
I still use a lot of IR.
It works great in many applications. And then after that, we're going to be talking about speaker level distribution. How do you? What we have
Still a lot of that.
You want music where? Speaker level distribution. So we'll talk about that next week as well. So feel free to come back in, check us out for those videos for that. It'll be Wednesday and Friday every week at 3 p.m. And so we will talk to you then at that point. So as always, reboot early.
Reboot often.
I'm Adam.
I'm Brent. We're out of here.
We'll talk to you next time, guys. Thank you.
Thank you.